In physics, we'll use trigonometry to help us find the components of a vector the same way you may have found the sides of a triangle before. We'll use the acronym SOHCAHTOA to help us remember that we use sine when we have the opposite and hypotenuse. Cosine relates the adjacent side and the hypotenuse, and tangent relates the opposite side and the adjacent side. In the triangle, the angle that we're looking at, the adjacent side is one of the sides that forms the angle. The opposite side is one of the legs of the triangle that does not form the angle, and the hypotenuse is always the longest side in the triangle. And so therefore, if I had to express sine of this angle here, theta, I would express that as the opposite side. So in this case, my opposite side I'm calling v sub y. For example, this is perhaps a velocity vector, and we're trying to find how much of the velocity is in the x direction, so v sub x, and how much of that velocity is in the vertical direction, v sub y. And I'll usually show little arrows here to help me remember which direction those vectors point. I would also then take my opposite over my hypotenuse, that would be over v for sine. Then for cosine, that would be the adjacent side, v sub x, over the hypotenuse, still v. And then tangent of theta would be the opposite, v sub y, over my adjacent side, v sub x. And so oftentimes what we'll do is if we know what v is, and we know what theta is, so let's say you throw something with a speed of 20 meters per second at a 30-degree angle, then we might want to find how much of that velocity is in the horizontal, v sub x, and how much of that is in the vertical, v sub y. So what we'll often do is we'll take our trig function and we'll multiply both sides by v, and we'll get an expression that looks like this. V times sine of theta is equal to v sub y, the component of the velocity in the vertical direction. I could do the same thing with the cosine function and multiply by v, and that would tell me that v times cosine of theta is equal to v sub x, the component of velocity in the horizontal direction. So oftentimes, instead of writing v sub x and v sub y, what we'll do is we'll replace v sub x with v times cosine of theta, and v sub y would be v times sine of theta. And we'll use these equations in our kinematic equations. As we've broken down the resultant vector, we'd call this the resultant. And these two are now called components. They are the components of that vector, and we use these trig functions to help relate the components to the resultant vector. Whenever you draw your vectors too, also make sure to show the arrows. They always start from the beginning, and if I follow the arrows for the components, I should end up where the vector ends, right here. Now, many students ask, well, what if we didn't have this angle theta? What if we had this angle over here? Let's call it alpha. How would I rewrite my components using this angle instead? Take a moment, pause the video, and try it yourself. All right, so hopefully you see that now that we have this angle here, then this side is the adjacent side, and this side becomes the opposite. This still remains the hypotenuse. So what I'll have to do is replace, instead of v sub y being v times sine of theta, I would say that my velocity in the y direction is v times cosine of alpha, and that's because cosine uses the adjacent side. Same thing for the x component. I would use v in the x direction now is v the hypotenuse times sine of alpha. So depending on whether or not the angle you're using is adjacent or opposite the side you're looking at, you'll need to make sure you're using the right trig function. There's no wrong way to do this. You know that sine of theta is the same thing as cosine of 90 minus theta. So in this case, your answers will be the same, the values you have will be the same. But these are two ways of expressing the components of a vector. We can also find the value of the hypotenuse, or the resultant vector, from the values of the horizontal and vertical velocity if we know them using the Pythagorean theorem. In this case, you'll notice I've dropped the vector hat notation because these are the magnitudes, or the just the value of the vector, not the direction itself. So then I can also take the square root of both sides to get this. And that will allow me to solve for perhaps the overall velocity given the two components. I can also use inverse trig functions to help find an angle. So let's say I don't know at what angle I launched an object, but I do know the overall velocity and then perhaps one of the components. Or I know both components, but I don't know the overall velocity. And I want to find the angle. I can use my inverse trig function. So using the same trig identities, SOHCAHTOA, we'd just take inverse of both sides and they would look like this. Of all three of these, the most common that we'll probably use in this class is the tangent inverse function. As you'll perhaps know, the horizontal and vertical velocities, but you won't know the overall velocity, which you can find with the Pythagorean theorem. So really, you could use any of these identities to find the angle of launch. If you are solving a problem involving numerical values, please also make sure that your calculator is set to degrees mode and not radians. Especially if you're using radians for your math class, easy mistake for students to forget to change to degrees. Again, only if you're solving a problem with numerical values does that matter, but make sure to check before you solve any values. All right, that is all the trigonometry you need for AP Physics 1. Thank you.